What is the difference between thermodynamic delta degrees, and biochemical delta? Imagine you're watching a chemical reaction unfold. You might wonder, how do scientists tell if that reaction will happen on its own or need a push? That's where Gibbs free energy comes into play. It helps us understand whether reactions are likely to occur naturally or not. But there are different ways to measure this energy change, and knowing the differences can make a big difference in how we interpret reactions in labs and living cells. Thermodynamic delta is the real-time change in Gibbs free energy for a reaction happening under specific conditions. It considers the actual concentrations of reactants and products, the pressure, and the temperature at that moment. If this value is negative, the reaction can happen spontaneously at those conditions. If it's positive, the reaction won't happen without energy added. This value can change as the reaction progresses because the concentrations of substances change. It's like tracking the energy state of a reaction as it moves toward or away from equilibrium. Standard Gibbs free energy change, written as delta degrees, pronounced delta G standard, is a fixed number. It tells us the energy change when all reactants and products are in their standard states, which usually means at a pressure of 1 bar and a concentration of 1 molar. This value is calculated from standard enthalpy and entropy values, which are measured under controlled conditions. Think of it as a baseline or reference point that helps scientists compare reactions under the same conditions. It doesn't tell us if a reaction will happen in real life but shows how favorable the reaction is under standard conditions. Biochemical delta, often written as delta prime or delta degrees prime, is a version tailored for reactions inside living organisms. Cells operate in a watery environment at a pH of about 7, with ions like hydrogen and magnesium present. Because of these differences, biochemical delta adjusts the standard delta to reflected actual cellular conditions. It accounts for the concentrations of reactants and products inside cells and the pH level. This way, it helps predict if a reaction will proceed spontaneously in a biological setting. The biochemical delta is related to the standard delta by including the reaction quotient, which considers the actual concentrations of substances involved. To sum up, thermodynamic delta shows us what's happening at any given moment, depending on the current state. Delta degrees gives us a fixed reference point based on standard conditions, making it easier to compare different reactions. Biochemical delta adapts this information for the environment inside living cells, helping us understand how life's processes happen despite the energy challenges. Knowing these differences helps us see how reactions can be spontaneous in one setting but not in another, and how cells can drive reactions that seem energetically unfavorable by changing conditions or coupling reactions together. This understanding connects directly to how entropy and spontaneity work, and how systems reach or maintain equilibrium.